So today in class, we talked about simplifying radicals and some properties with rads to get ready for Unit 8. So this warm-up radical review is the very first document in the Unit 8 warm-up and homework packet. So you do have a copy of this from when I gave you all of the notes for the rest of the semester. But again, it's in the next unit. So you want to move to your Unit 8 stuff and find that first page says warm-up radical review. So we've already reviewed this concept that we use perfect squares to simplify radicals. We've been using that earlier in the year for previous units. So for example, when I look at 50, I know that a factor of 50, that's a perfect square, would be 25. So I'd break 50 into 25 times 2, and that's how I simplify my rad down to 5 rad 2. Or we looked at the square root of 32 can be broken into 16 times 2, and the square root of 16 is 4, gives me 4 rad 2. Okay, and then here was our example with 98. From there, the students who were in the building today went through and practiced this with a few examples, and I'll upload this so that you can also try these on your own and make sure that you understand this concept of how to simplify rads. Now, we use this to do several things this unit. So one thing we do is solving equations with rads. So I'm actually going to rewrite the equations that I have here and then discuss each. So when we are solving, oops, wrote that wrong, and we have a radical involved, what we talked about in class today is that we have to rationalize the denominator. So we're still using inverse operations to solve, where I'm saying the inverse of multiplying by rad 2 would be to divide by rad 2. And that would just cancel out my rads and help me solve for x. And in this first example, it works out nicely because the rad 2's cancel on both sides, and I just get x equals 16. On the second example, this is supposed to be a rad 2 here. When I go to divide by the square root of 2, it'll cancel and leave me with just x, but it doesn't cancel over here. And we cannot leave a radical in the denominator. That's an Algebra 1 concept. And so what we do is what's called rationalize the denominator, where we multiply the top and bottom of my fraction by rad 2 over rad 2. And what that does is in the numerator, it gives me 10 rad 2. But in the denominator, I have rad 2 times rad 2, which gives me the square root of 4, which is a perfect square, and is just 2. So by multiplying the radical by itself, we create a perfect square and therefore get rid of that radical in the denominator, leaving me with just regular 2. Or as I say in algebra class, rad 2 times rad 2 gives me regular 2. Okay. Then we look to see if we can reduce. So we can reduce numbers that are inside radicals with other numbers that are inside radicals, or we can reduce numbers that are outside radicals with other numbers that are outside radicals. So this would reduce to just 5 rad 2. So I can't reduce here because that's in and that's not. But because these are both numbers outside a rad, I can reduce that. On this next example, we need to divide by rad 3 to solve for x, and we'll be doing a lot of this when we solve for special rates. And I can't leave that rad 3 in the denominator, and I can't reduce this either because that's out of a rad and that's in. So I rationalize that denominator, and in the numerator, it's going to give me 24 rad 3. And the denominator, rad 3 times rad 3, gives me rad 9, which is a perfect square and brings me back to 3. Then I reduce where I can, and in this case I have 8 rad 3. And I think actually I think I wrote down, yeah, I missed a piece of that one. That's okay. This example's fine too. Okay. So then the students in class today, they did a few examples, just 2, and you can do those as well and check it against what I have here. The last skill that we worked on today was adding and subtracting rads and a review of that. So when I add and subtract radicals, so here's let me cover up the bottom part of my example. Here's an example of wanting to add some rads together. first thing I do is I simplify all of my rads, so each term. Now my first term here is already simplified. There's no perfect square factors left inside this radical. But the square root of 18, I can break into 9 and 2. And 50, I could break into 25 and 2. So I simplify any radicals that I can. So you can see I simplified 18 and 50. And then I go through and I add up any of my like rads. And like rads would be any rad that has the same value inside the radical. So these are all rad 2's, which means I can combine them all. And I just add up my coefficients. So 5, take away 3 is 2, plus 5 more, gives me 7 rad 2's altogether. Then we looked at the fact that we don't always have like rads. And so sometimes, like you can see on these examples, I have more than one term in my final answer. That's fine. The rad 3 stays by itself, and I can combine those that are alike. So in this case, rad 5 with rad 5. So again, this is what the students in class did today. You can take a minute, kind of follow these rules, try these problems, and then check it against the key. Then homework today, what you're going to do is just a little radical review. So simplifying rads, adding and subtracting rads, just kind of to get back into this practice because we use those skills quite a bit in Unit 8.